Bismillahirrahmanirrahim. Welcome to the quantity survey course. In this lecture, we will discuss the BBS of column, bar bending schedule of column. So, we start. Here in front of us, this is the elevation view of the column, and this is the slab, and this is the column. Stirrups, these are the column longitudinal bars. Total weight and height of the column from this development length induced in slab from here to this overlapping length with the footing of the column longitudinal bars. We total have the height of the column 4000 millimeter. We already did the subtraction of concrete cover from the height of the column. So total height we have 4000 millimeter of the longitudinal straight bars without these bends, this LD length bend and this overlapping length bend in the footing. This is footing. So this is how column is structured. And in the column at the footing, the longitudinal bars overlapping length with the footing we provide almost in most of the cases 300 millimeter. So that's why here we provide the overlapping length in the footing 300 millimeter. And the stirrups at the ends, the spacing bit of the stirrups at the ends L by 3, this is ends L by 3 and this is L by 3 end. At the end we have spacing 150 millimeter, and at the mid of the span of this column we have spacing 200 millimeter. I will show you this all thing in section view also. This is the development length that the column longitudinal bars are bent toward the slab from both ends, and here for bends towards the footing. So the LD formula is the development length formula. We already know that. If in any case, if there is the lapping between two bars in the middle portion of the longitudinal bars, you have to consider overlapping length, but here we don't have, so that's why we are not considering it, but we are just considering the development length and this overlapping length with the footing. So we see the section view. In the section view you can see that we have the horizontal. In the section view you can see we have 4 vertical bars of 16 millimeter dia, and here cross section you can see 300 millimeter and 400 millimeter of the column, and the vertical bars are thus dia of 16 millimeter. Clear cover from all the sides of the column is 40 millimeter, and the stirrups we are using here 8 millimeter, and the spacing 150 millimeter at the ends of the column, and at the mid of the column 200 millimeter spacing between the stirrups. So this is our today topic, bar bending schedule of the column. So I hope no question is clear. We move further to solve the numerical. Here we first see the given data. Height of the column 4000 millimeter after the subtraction of the concrete cover 400,000 millimeter, and the cross section of the column is 300 by 400 millimeter. Cross section of the column 300 by 400 millimeter, and clear cover from all sides is 40 millimeter. Diameter of vertical bars 16 millimeter. Diameter of stirrups is 8 millimeter, and the stirrup center to center spacing at the rate 150 millimeter at ends while 200 millimeter at mid span. So let's start first. Vertical bars of 16 millimeter dia, cutting length for one vertical bar. Here is the formula: height, total height of the column excluding the concrete cover, after the subtraction of concrete cover, plus LD, development length. LD formula for development length. Here you can see in the elevation view the these bars are induced to the slab, so here bends. So this is development length, how much we require, we calculate it by formula LD. So this is, here we use the formula LD plus lapping length with footing lapping length of the column longitudinal bars with the footing. This is the lapping length, 300 millimeter for each longitudinal bars. So next, minus bend deductions. For one longitudinal bars, we have two 90-degree bends for each longitudinal bars. I want to show the 90-degree bends in elevation view of the column. Here for one longitudinal bar we have two 90-degree bends, so we will deduct two 90-degree bends in the formula. Minus bend deduction will be 2d. For one 90-degree bend we have formula 2d, we multiply it with 2 because we have two 90-degree bends. So let's we calculate the cutting length of one bar. Solve this. Let me calculate it on the calculator now. First we put here dia, we have 16 millimeter, and here dia we have of the longitudinal bar 16 millimeter. So let now me calculate it on the calculator. So 50 into 16, 50 into 16 we have 800 plus 300, we 1100, it's 1100, 4000 plus 1100, we have 5100 minus 16 into 2, 32, 32 into 2, 64 minus 64. So we have 5036 millimeter, 5036 millimeter cutting length for one bar. For 4 bar, we are having a 4 vertical bars in our column, then multiply the one cutting length of bar with 4, 5036. So let me calculate it on the calculator. 5036 multiply with the 4 will give us 20,144. Here we will put 20,144 millimeter is the total cutting length for the longitudinal bars. Total cutting length for, so 5036 millimeter is the one cutting length for one bar. Let's we multiply it with the 4, 5036 multiply with the 4, total length we have 20,144 millimeter. Here you can see, so total length we in millimeter we have 20,144 millimeter. In meter we will divide it by 1000, it will give us 20.144 millimeter. So 1 meter, 20.144 meter is the total vertical bars, 4 number of vertical bars. Total length required, cutting total length required is 20.144 millimeter, 20.144 meter. Let's we calculate the weight of the all vertical bars. We have 4 vertical bars. Dia vertical bar is 16. So let we solve it. 16 into 16, 60 into 62, multiply here meter we have 20.14. Okay, remember this is the total length of all 4 vertical bars used in our column. So let me calculate it on the calculator. 16 square 256 divided by 162 1.58, then multiply it with the 20.144, total 31.83. It's mean we required vertical bars weight 31.83, that we take it 32 kg. Total weight for 4 vertical bars we required in our column is 32 kg. Now let's move to the stirrups. We divided the stirrups length into two ways. At the ends we have two ends of the column, and at mid span we calculated the length into two ways, at the ends and then at the mids, because we have different spacing at the ends of the columns of the stirrups. Spacing at the end of the stirrups we have 150 millimeter, and the stirrup spacing at the mid span of the column is 200 millimeter. So that's why we divide it into the two parts. Here I want to show you in the elevation that this is the column, this is the one end, and this is the this is other end from here to here, and this is the mid span of the column. Formula to calculate the ends of the column is L by 3. L is the effective length after subtraction of concrete cover, that's called effective length. Let's we calculate the number of stirrups at ends. First we will calculate number of stirrups at one end, then we multiply it with the 2 to calculate the number of stirrups at two ends of the column. So effective length we have of the column is 4000, because we already subtracted the concrete cover from it. 4000 by 3 will give us, let me calculate it on the calculator, 4000 divided by 3, so 1333, 1333.33 millimeter. We have one end's length. Number of stirrups at one end, we will divide the effective length with, this is the one end length, so we will divide the end's length with the spacing plus 1. This is the formula. End's length, one end's length we have 1333.33 millimeter divided by 150, which is the spacing, plus 1. This is the formula. Let me calculate it on the calculator. See here, now one is already here. Divide it by 150 spacing at the end, so it will give 8.88 plus 1, 9.88. Let we take it 10, 9.88, let we take it 10 number of bars, number of stirrups required at one end. So we have two ends of the column, so let's we multiply with the 2. It will give us the 20 total number of stirrups required for our column. 20 number of stirrups required for our column at the ends, just at the ends. So let's move further to calculate the number of stirrups at mid spacing. We know that at mid end, first we will calculate the mid length. So mid length calculation, total length we have after the subtraction of the concrete cover 4000 millimeter. So subtract it, two ends lengths, subtract the two end length from the total length. So one end length is 1, let me calculate, 1333 33.33 millimeter is the one end's length, multiplied with the 2 because we will subtract two ends length from total length. This will give us the mid length of the column. So let me calculate it on the calculator. 2 into 1333.33, 2666.66, subtract it from 4000. So this is the plus sign here. 1333.34, 1333.34 millimeter is the mid length of the column. So we calculate the number of stirrups required at the mid span of the column. 1333.34 divided by 200 plus 1. Let me calculate it on the calculator. 1333.34 divided by 200, because we have 200 millimeter spacing at the mid span of the spacing of the stirrups. 200, so plus 1, 7.6. Let me take it 8. Let me take it 8. So total number of stirrups, we have 20 number of stirrups at the ends and 8 number of stirrups at the mid span of the column. Total we have 28 number of stirrups. So let's move further to calculate the cutting length of the stirrups bar. Here this formula is we already have discussed in the last lecture, that A is the horizontal length of the stirrups. First we will calculate the horizontal length of the stirrups, then B is the vertical length of the stirrups. Horizontal length in the section minus 2 concrete cover minus 2 half of the diameter of the bar. So horizontal length, we have the section of the column 300 by 400. So horizontal length we have 300 in the section minus 2 into concrete cover, we have 40 millimeter, one concrete cover, to multiply it with the 2 to subtract the 2 concrete cover from both sides, minus 2 into 4. Diameter of the stirrup is 8 millimeter. We here in formula take the half diameter of bar, because we go from the center to center, that's why we multiply it with here with 2 and the half diameter of bar. So minus 2 into 4, half diameter of 8 millimeter, half will be 4, so that's why here we put it. Let me show you the what is horizontal length and B is the vertical length. Vertical length, we just take the vertical height in the section. Vertical height in the section we have 300 by 400 millimeter is the column section, so here 400 millimeter vertical height in the section, minus 2 concrete cover, 2 into 40, because we have concrete covers 40 millimeter, minus 2 half of the diameter of the bar, so 2 into 4. Okay, let me show you the in the section we view the horizontal length and vertical length of the stirrups. Here is the section view. This is the stirrups. Sorry for that. These are the stirrups, and these are the hook length. Two hook length for one stirrups at 135-degree bends. So one hook length. This is the horizontal length of, and this is also horizontal length. So for one stirrup we have two horizontal length and these two vertical lengths. So this is referred as A and this vertical length is referred as a B, 300 millimeter and 400 millimeter. Now let me calculate the A horizontal length of the stirrups on the calculator. We have 300 horizontal length in this section, 300 minus 2 into concrete cover, 40 into 2, 80, minus 80, 220 minus 2 into 4, 8, minus 8, 212 millimeter. So horizontal length of the stirrup is 212 212 millimeter, and the vertical length of the stirrups, let me calculate it on the calculator. 400 minus 2 into 40, 80, minus 2 into 8, 4, 8 minus 8, 312 millimeter is the vertical length of one stirrup. 312 millimeter. Let's move further. We just calculated the horizontal length and vertical length of stirrup. Now calculate the cutting length required for one stirrup. Formula to calculate 2 into A. A, you know, that is the horizontal length of one stirrup. Multiplied with the 2 because we have 2 horizontal length of one stirrup, and B is the vertical length of the stirrup. We just multiplied with the 2 because we have 2 vertical length of one stirrup, plus hook length. We have 2 hooks for one stirrup minus bends. So here in formula you can bends, we have in one stirrup we have 3 90-degree bends, so that's why we multiply the minus 3 into 2d. 90-degree bend, we have formula 2d. We have 2 hooks of 130-degree bend, so that's why we multiply in one stirrup. That's why we multiply 2 into 3d. For 135-degree bend, we have formula 3d. So let me calculate it by just putting the values. For A, horizontal length of the stirrup is 212 millimeter. Just let me put the values. B 312 millimeter, and the hook length we have 10d. So 2 hook length, that's why we multiply with the 2 hook length. Is dd the dia, we have 8 millimeter dia of the stirrup. Here bend detection of 390-degree bend detection, multiply with the dia, we have 8, and these are the 135-degree bends, 3D dia, we have 8 millimeter of the stirrup. So let me calculate this cutting length required for one stirrup on the calculator. 2 into 212, 2 into 212, 424, 424 plus 2 into 312, 2 into 312, 624, 624. Here you can see 2 into 10, 20, 20 into 80, 80 into 10, 80 into 2, 160 plus 160 millimeter, minus we have 8 into 2, 6, 3 into 2, 6 into 8, 48, 48, minus 2 into 3, 6, 6 into 8, 48, same. So finally let me calculate it on the calculator now. 424 plus 624, 401 plus 624 plus 160 minus 48 into 48, that's 96, minus 96. So total cutting length for one stirrup we have 1112, 1112 millimeter. So let's we calculate the total cutting length required for all stirrups. Thus we will multiply the number of the stirrups with the one cutting length of the stirrups. Number of stirrups we have 20. Let me show you how number of stirrups 8 and 20. 20 plus 8, 28. We have 28 number of stirrups. 20 at the ends of the column and 8 at the midspan of the column. Total we have 28 number of stirrups multiplied with the one cutting length of the stirrups, 1112 millimeter. So let me calculate it on the we already put it multiplied with the 28 number of stirrups. Total we have 31,136. 31,136 millimeter total length, cutting length required for the stirrups. So in just divide it by 1000 to calculate in meter. So it will give us 31.136 meter total cutting length required for stirrups. Let we finally calculate the weight of the stirrups required. 8 into 8, this is the dia of the stirrup the bar, 8 square divided by 162. Length we have 31.136. 31.136. You are very familiar with this formula. This is the formula to calculate the weight of the bars. D square by 162 into length. D is dia in millimeter and the length we put in the meter. So here it will give the weight in kg. Let me calculate it on the calculator now. 8 square 164 divided by 162, 0.395, then multiply it with the total length of the stirrups, cutting length of the stirrup, 31.136 meter. Then so weight we required for the stirrups, total weight 12.3 kg, 12.3 kg. So let's we calculate the total weight of the steel required for our column. For vertical bars we require the weight. Here I want to show you weight we calculated for the vertical bar is 32 kg. So for stirrups it's 12.2. 32 for the vertical bars was for the stirrups we weight required 12.3. So total it will give us the, let me calculate it on the calculator, 12.3 plus 32, 44. So let we take it 45 kg weight we required for total weight required. Also sorry, it's total weight 45 kg, 45 kg total weight for the column of the steel we required. So thanks for watching this lecture. Here I want to show you the technical, what was the technical point about this lecture. Technical point was that here LD length which is induced to the slab, this is slab showing here, and this column length, development length, called that length which is induced in the slab. And here more thing we did, this is the lapping length of column longitudinal bar with the footing bars. So footing, actually you cannot see the footing bars here because we are already cleared the lecture of footing, so that's why I did not show the footing here. The reinforcement of footing we did not show here, but these longitudinal bars of the column are overlapping with the column footing, so that's we take it 300 millimeter. So that was the lecture. I hope that's clear. Thanks for watching this lecture. Please stay tuned for next.